Nuclear and particle physics is the branch of physics that studies the fundamental particles of the universe and their interactions. This field explores the smallest building blocks of matter and the forces that govern their behavior. It bridges the understanding of subatomic particles to the complex structures they form, such as atomic nuclei. By delving into this realm, scientists aim to uncover the secrets of the universe's most basic components. The journey into nuclear and particle physics began in the early 20th century. In 1896, Henri Becquerel discovered radioactivity, revealing that atoms are not indivisible. In 1911, Ernest Rutherford's gold foil experiment led to the discovery of the atomic nucleus. By 1932, James Chadwick discovered the neutron, a neutral particle in the nucleus. The 1940s and 1950s saw the development of quantum mechanics and the discovery of numerous particles like hadrons, leptons, and mesons in cosmic rays and accelerators. In the 1960s, the quark model was proposed by Murray Gell-Mann and George Zweig, explaining the internal structure of protons, neutrons, and other hadrons. In the standard model of particle physics, particles are classified into two main groups, fermions and bosons. Fermions make up matter and are characterized by having half-integer spin. Quarks, which combine to form protons, neutrons, and other hadrons, come in 6 types: up, down, charm, strange, top, and bottom. Leptons include the electron, muon, tau, and their corresponding neutrinos. Bosons, on the other hand, are force carriers and have integer spin. The photon mediates electromagnetic force. The gluon mediates strong nuclear force between quarks. W and Z bosons mediate weak nuclear force, and the Higgs boson is associated with the Higgs field, giving particles mass. 4 fundamental forces govern the interactions between particles. The gravitational force is the weakest, but acts over long distances, affecting massive objects. The electromagnetic force acts between charged particles, responsible for electric and magnetic phenomena. The weak nuclear force is responsible for radioactive decay and neutrino interactions. Lastly, the strong nuclear force binds quarks together in protons and neutrons and holds the atomic nucleus together. This subfield focuses on the atomic nucleus. Nuclear structure studies the arrangement and behavior of protons and neutrons in the nucleus. Nuclear reactions examine processes like fission, the splitting of a nucleus, and fusion, the combining of nuclei. Radioactivity investigates the spontaneous emission of particles or radiation from unstable nuclei. These studies are crucial for understanding the stability and transformations of atomic nuclei. This subfield explores the fundamental constituents of matter and their interactions. Particle accelerators are devices that accelerate particles to high speeds and collide them to study fundamental interactions. Collider experiments, like those conducted at CERN's Large Hadron Collider, aim to discover new particles and verify theoretical models. The standard model is the prevailing theory describing the electromagnetic, weak, and strong forces, and classifying all known subatomic particles. Advanced topics in nuclear and particle physics include quantum chromodynamics, or QCD, the theory of the strong interaction describing how quarks and gluons interact. Electroweak theory unifies the electromagnetic and weak forces. Research areas beyond the standard model include supersymmetry, string theory, and dark matter, pushing the boundaries of our understanding of the universe. Nuclear and particle physics have numerous practical applications. In medical imaging and therapy, techniques like PET scans and proton therapy are used for cancer treatment. Nuclear energy utilizes fission and potentially fusion for power generation. In material science, the properties of materials at the atomic level are investigated. Security applications include techniques for detecting illicit nuclear materials. Nuclear and particle physics is a dynamic and fundamental field of science that seeks to understand the building blocks of the universe. From the tiniest particles to the forces that shape the cosmos, it combines theoretical and experimental approaches to unlock the mysteries of matter and energy. As research progresses, it holds the potential to revolutionize our understanding of the universe and drive technological advancements across various fields.